Good morning. We are on 8.11, experimental probability. This is on page 502. Experimental probability of an event is based on a particular experiment or experiments or trials' previous data. This is opposed to the theoretical probability. Now, theoretically, if I flip a coin, I have a 50% chance of having a head. If we compare that to experimental probability, is I will flick the coin a number of times, see how many heads I get out of, or what's the probability of getting a head, and then use that result. That will be the experimental probability. Now, how do I find this? The experimental probability is the number of times that an event occurs divided by the total number of trials in the experiment. It's really straightforward, and you'll see how easy it is when we get to the examples. Another thing that I can get, and this is not only with experimental probability, is the expected number of occurrences. This will be the probability times the number of trials. And let's do a quick example. If I say the probability of getting a tail is 50% or 0.5, and I chuck the dice the number of times, and I flip it 20 times, I would expect to get 10 tails. That will be the expected value. Now remember, this expected value will be the probability times the number of trials. In that case, it will be 0.5 times 20. So I can expect around about 10 tails. This is then not what it will be, but what I should get. Looking at example 16, working with experimental probability, a number of red, white and orange marbles are placed in a jar. Now we can't use the theoretical probability, because we don't know how many there are. So what we've done is repeatedly a marble is taken out, the color is noted and is then replaced into the jar. The results are tallied in the table, and now they're going to ask us a couple of questions. Again, I can't use the probability theoretically, because I don't know how many there of each color is. So what I can do is I can only use the results that they've given me. So if we look at A, what is the experimental probability? And there's no different way than writing it as theoretically. So what I will do is I'll say the probability of getting a red marble is being chosen next. Now I have chosen, and I'm just going to write it in here, I have 8 times I got red, 12 times white, and 10 times orange. So it means that my total number of times that I got marbles out would be 30 times. So the probability of getting red would be 8 out of a total of 30. Remember, I always have to simplify 8 out of 30, and that will give me 4 in 15. I don't have to write it as a decimal. I can write it like that. For B, what is the experimental probability of a red or a white marble to be chosen? So the probability to have a red or white will be any one of, so it will be, it can either be 8 or 12, so any one of these two, so together there's 20 of them, so that will be 20 out of 30, and if I simplify that, my answer is 2 and 3. Now, if the experiment is done 600 times, so in C, the number of times that I do this experiment is 600 times, so 600 times I'm going to pick up a ball. What is the expected number of times that an orange marble will be selected? So I can say that the expected value will be the probability times the number of times that I've done it. So first of all, I have to find what's the probability of getting an orange ball. Well, the probability is 10 out of 30, or 1 in 3. That means 1 over 3 times, and I've done this 600 times, so I will expect that I will find 200 orange marbles. This is not a guarantee, but more just what it should be. Exercise 8K, I would like you to do all of the problems as on your timeline. Thank you.